Okay, geometry fans, today we're going to talk about inscribed angles in circles. Okay, and we're going to do a couple of things here. First of all, just to talk about what is an inscribed angle. In this picture here, there are two angles that we're going to measure. And the first measurement that we're going to make is angle BAD, and then the second angle that we want to measure is BCD. Now, angle BAD is something that we looked at yesterday, or we looked at this the other day. Angle BAD is what we call a central angle. So BAD is a central angle, and that means that the angle's vertex is right here at the center. Okay, so it's a central angle. Let me zoom in a little bit here. And that means the vertex of the angle right here is at the center of the circle. Okay, now let's go ahead and use a protractor and measure this. So for angle BAD, I'm going to line up the protractor at the vertex at A. And then this side of the angle is going to point to 0, and then we're going to travel all the way around. And then I'm going to extend AB, and we get approximately, I would say that's about 112 degrees. Okay, it's kind of hard to see on my paper here, but that's about 112. Okay, so let's go ahead and we'll label that in this picture here, 112 degrees, and on the side, the measure of angle BAD is 112 degrees. Now the second angle we want to measure is angle BCD. Now if you had to take a guess, what do you think the relationship will be with this angle measure, BCD, and angle BAD? Okay, you can just kind of guess in your head, and let's go ahead and see what happens here. So let's measure this. So I'm going to take the protractor again. I'm going to put it on on the vertex, point C. Okay, I'm going to line it up, the bottom part of the protractor, with this side of the angle. Now, CB, where does that hit the circle, hit the protractor? That's about 56 degrees, I would say. It's about 56. Okay, so let's go ahead and we'll write that in here, 56 degrees. Now, something that you might notice about this, if you look at 112 and you look at 56, you'll notice that 56 is half of 112. All right, now that's kind of interesting that that relationship happens. Let's do a little vocabulary here first. When you have the vertex of the angle, the vertex is at point C. So here's angle BCD. This kind of angle is called inscribed. Okay, that is called an inscribed angle. That is an inscribed angle. So we had a central angle, which is at the center. An inscribed angle, the vertex is on the circle, and both sides of the angle are inside. Okay, so the official definition here is that the vertex is on the circle. The vertex is on the circle, and then the sides of the angle, are inside the circle. Okay, so we're going to be talking about inscribed angles today. Now, I want to show you a proof. It looks like from our measurement that the inscribed angle is half of the central angle. Okay, and one other piece of vocabulary here I want to mention is that the arc BD, which yesterday we talked about, this is a minor arc, is what we call the intercepted arc. If you trace out angle BCD, where do the two sides of the angle hit the circle? They hit at point B here, and they also hit at point D here. Now the arc between those is called the intercepted arc. All right, it's kind of like if you're playing football, if you intercept the ball, that's where the defense cuts in front of the offense to get the ball. An intercepted arc is you look at the angle, where does it cut off? Where does it cross the circle? Here and here, it cuts off this arc. It intercepts it. Okay, so that's going to be an important idea as well. Intercepted arc. That's some vocabulary that you'll see quite a bit. Okay, we're going to do a little proof here. And we're going to say that x degrees, that is the angle, the inscribed angle, right here. We have the center of the circle, and we're going to draw, let's create a triangle. Almost all the proofs we do are triangle proofs. I'm going to connect, let me use a red pen here. Here. I'm going to connect the center to this point right here on the circle. And what that does is that gives me this triangle here. Not only does it give me a triangle, but it also gives me a very special kind of triangle. Because one thing that you always know is that in a circle, all of the radii have to be congruent. So that this radius here and this radius here, those are equal. So what kind of triangle is this where two sides are congruent? It's isosceles. In an isosceles triangle, if you have two congruent sides, then you know that the opposite angles have to be congruent. So that if this measure is x degrees, this measure is x degrees. All right, now what that tells us, where that leads us, is that, okay, if this is x, look at the central angle. Okay, the central angle is right here, where the vertex is at the center. This angle is an exterior angle to this triangle. And we have a relationship that says the exterior angle is equal to the sum of the two remote interior angles. So if I take x plus x, I get 2x degrees. 2x degrees. That would be the measure of the central angle. And then yesterday we talked about the fact that the central angle has to be the same measure as its arc. The central measure is equal to its arc measure. So if this is 2x degrees, then the arc measure is also 2x degrees. Now look at the relationship. The inscribed angle. Okay, we'll write it down here on the side. The inscribed angle equals x degrees. The central angle, okay, or we'll say the intercepted arc, okay, the intercepted arc equals 2x degrees. So what's the relationship? Well, the inscribed angle is always going to be half of the intercepted arc. X is half of 2x. This will always be true. Okay, so what we've done here is we've proved a theorem. All right, this is one of our rules in geometry. And what it says, okay, at the bottom here, theorem, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of the intercepted arc. Okay, so basically what that says, let's go ahead and draw a couple examples here. And I'm just going to freehand a circle. But let's say you have this circle, and we say that the arc measure here is 80 degrees. And we'll say the intercepted, or we'll say that the inscribed angle is x. Okay, so the arc measure is 80, the inscribed angle is x. Now this is true anytime the vertex is on the circle. If it's not on the circle, we can't do this. Now, if I trace this out, where does the angle hit the circle? Here. Here. The arc between them is 80. So that means that x is half of 80. X must be equal to 40. Okay, and you can think of it as 80 divided by 2. X is equal to 40 degrees. All right, let's do another example. I'm going to give you a bunch of examples today. Let's do this. Okay, let's say that this is 120 degrees, and we'll call that x degrees. What would be the measure of x, the inscribed angle? Well, half of 120, 120 divided by 2, is 60 degrees. That's x. So x is 60. What happens if we work the other way? What if we say that the angle, the inscribed angle, is 50 degrees? Now we want the arc measure. So the arc is x degrees. Okay, the angle measure, inscribed angle, is 50. Well, we know that 50 has to be half of x. 50 equals half of x. All right, now if you want to solve that equation, all you have to do, multiply both sides by 2, and you get 2 times 50 is 100. And then 2 times 1/2 just reduces to 1, equals x. So x is equal to 100. So basically, you don't need to do this equation every time. If you have the angle, if the angle is half of the intercepted arc, then that means that the arc is 2 times the angle measure. 2 times 50 gives me 100. If I know the arc is 120, half of 120 is 60. That's the inscribed angle. Let me give you one more example here on this side. Let's say we have, here's a circle, and let's say we have an angle that looks like this. And we'll say that this angle measure here, this is x degrees. We don't know that. But what we do know is that the arc measure is 94 degrees. And what we want to do is to find x. Now this looks different. Technically, we don't call this an inscribed angle because even though the vertex of the angle is on the circle, this side is not in the circle. So it's not an inscribed angle. However, it doesn't matter. If the vertex is on the circle, the angle measures half the intercepted arc. So what's half of 94? 94 divided by 2, and we get x equals 47. That's it. That's all we're doing today. Okay, so let's summarize what we know here. Yesterday we talked about if you have a central angle, then the arc measure is the same. Central angle is same as the arc. But if the vertex is on the circle, the point is on the circle, then we know that it is 1/2 of the arc measure. On the circle is half. So you're going to hear me say this quite a bit. Central angle, it's the same as the arc. On the circle is half. On the circle is 1/2. Okay, now let's go on to the other side here. We have a couple more rules we want to look at. Okay, so these are two special cases, two theorems here. If an angle is inscribed in a semicircle, then the angle is a right angle. So if an angle is inscribed in a semicircle, well, let's do this. Let's draw a circle. Let's draw a diameter because that will create a semicircle, right? We have two circles, or two half circles now, two semicircles. And let's pick a point on the circle, and then we'll create an angle. Okay, so here's our angle. We'll call this x degrees, right here. We want to find that measure. Well, here's the thing. If I trace this out, where do I hit the circle? Here. And I hit the circle here. Look at the arc between those 2 points. That's a semicircle. Now you know that all the arc measures add up to 360. So that means that half of that is 180 degrees. Now, if we have an inscribed angle like x, you know it's half of the intercepted arc measure. So if this is 180, then we know that x equals 90. This is always true. This case will always give you 90 degrees. If an angle intercepts a diameter, okay, if it's inscribed in a semicircle, then it has to be a right angle. Always true. Okay, and the last one here, this is a special case. If you have a quadrilateral inscribed in a circle, inscribed, all that means is that all the vertices are on the circle, and then all the sides are inside. Okay? If you say something's inscribed in a circle. Well, what happens here is that if I call this angle 1 and I call this angle 2, if I look at angle 1, where does it hit the circle? Here, here. So there's my intercepted arc. Now if I do the same thing though with angle 2, and I trace out angle 2, the sides, where does it hit the circle? It's going to hit at the same 2 points it's going to intersect, and then here's the arc. So if I add these up here, well, angle 1 and angle 2, notice that the intercepted arcs create the whole circle. So that's a total of 360. Now the problem is that these are both inscribed. So the total is going to be half of 360, which is 180. So what happens is that angle 1 plus angle 2 is always going to be equal to 180 degrees. So the opposite angles are supplementary 180 degrees. This is for an inscribed quadrilateral. All right, let me zoom in so you can see that there. That says supplementary 180 degrees, angle 1 and angle 2. Okay, now those are the notes. I'm going to stop the video for a moment. This is part 1, and in part 2 we will do the examples that are down here at the bottom.